Good. Well, I wanted to give a few minutes to let people find the room. I know there's a room mix-up, so some pump-up music. Hopefully, everyone's familiar with The Matrix. If not, some of my storytelling might fail today. So to set the stage, my agenda, I want to start with a little introduction about myself and what led me to be here today. And then I'm going to give a little history about the evolution. Hey, Aiden. I want to help demystify what is an agent by tracing the steps of how we got here. And then I'll do a little show and tell, show you the tools that I decided to use for this talk, and a real-world business story where I helped a local entrepreneur apply agents in his line of work leading up to this talk. It's going to be relevant to you, Mike. So time permitting, I'd like to end with some use cases, hear how you guys might be using agents or LLMs in your businesses, and just have a conversation if we have enough time. So today's talk is going to be somewhere between beginner and intermediate. I call this a blue-green. And yes, I had AI create this very cool image for me. A little wonky, but I think it turned out all right. So if you have a PhD in deep learning architectures and transformers, this may not have the moguls that you're looking for today, just a heads up. But what it is, or what I hope it will be for you, is a primer on agents, what they are, how they operate, and how you can harness them to complete tasks for you. Working smarter, not harder. That's always been the goal. I'd like to help you not fall behind the curve of technology to the point where it's just so hard to catch up. And we will build into some examples of how to create these agents, and I'll share some code and how it is all set up from that side. So let's begin. So in terms of an introduction, I'm Nick. You can see my clever domain name because I'm Nick Terkay, so the first two letters of my first and my last name, so you can find anything about me there. I live here in Boise in Southeast, just off the Greenbelt, close to the stadium. I moved here from Chicago a little over 5 years ago, and I've lived in quite a few cities, but I'd like to take you a little further back. I grew up in Pittsburgh, and I was really lucky to have access to Carnegie Mellon. They gave us courses in middle school and high school, and really got me into computers at a young age. And then in 1999, a movie came out called The Matrix, and I was in 9th grade, and that was like a very pivotal moment of my life. Got really into programming and coding, and was lucky enough to have those classes through high school. So fast forward, I did move to Colorado, University of Colorado, Boulder, and I did my CS degree there, my bachelor's and my master's. And yeah, 1 year later, 2003, the second two Matrix movies came out. And this left an even deeper impression on me and the theory of mind and society of mind. So there was a program called the Cognitive Science program, which focused on linguistics and psychology and philosophy. And so I took all of those courses to get that certificate, and really was so passionate at the time. And this was 20 years ago. This is more than 20 years ago. So the coding tools and the computing resources are not even close to what they look like today. But then you have student loans and you focus on a career. And I got into mobile and cloud development. So these were starting to take off. So I just built a lot of apps and SaaS platforms. And this is what I really have done for most of my career. I'm not here to tell you I'm a PhD in AI. So I was lucky enough at my last role and in my previous role to use machine learning, things like clustering and categorization and quality scoring. And then in my most recent role, we utilized LLMs to save hours on delivering customer-facing reports, and really fine-tuning those over a matter of time. That was for a cybersecurity company. So now, in 2025, I've really been focused on the proliferation of agents. I mean, they're making tech headlines everywhere. It's kind of getting annoying, to be honest, but I'm glad that it brought you to this talk. I believe that while there is a ton of hype and fanboy behavior, the type of work that agents are enabling and this kind of software development, it's going to be here to stay. And it is a new paradigm, another buzzword. But over these next years, businesses will have different shapes and operating structures. You're seeing it today. 5-person companies worth $1 billion because they're just leveraging AI agents and AI everywhere in their business. So I think this has many implications for the workforce, and my motivation is to educate y'all and help others harness this and grasp the underlying concepts so that they're not left behind. And with that, we'll tie back. That's enough about me. So our main character for the day is going to be Agent Smith. He invited himself to hack for it. And I hope it will serve as an apropos analogy. I think it works. You'll be seeing more of him. So the evolution. So whether we like it or not, tech continues to evolve. Hardware advancements drive software innovations and vice versa. This loop and Moore's law, I mean, these are playing the critical role in the rapid changes in the AI space these past few years. And I'd like to break down how that tech has changed in recent history, leading to where we're at today, and providing an overview of what agents are. I'll focus on the software side. I mean, if you look at the GPU or the hardware side, there's a ton of innovation there, and it's just as influential, but it'll be out of scope today. After that, I'm going to dig into how agents think, act, and observe, and I'll show you how you can utilize them in a few different ways. So while I could go all the way back to 1950 when the Turing test was created, I'm just going to take a look at what's changed basically since I started my career and what's more recent and what we're seeing today. I chose 2008, so this is when the first iTunes mobile app store launched, and there was about 500 mobile apps there. Today, for reference, the iTunes store has 1.96 million apps, and the Google Play Store has 2.87 million apps available for download. So when you combine mobile apps with cheaper and easier to deploy cloud storage and infrastructure, things like Amazon Web Services, Google App Engine, you've got these always-on devices collecting all types of data, and a lower cost to store it meant companies started saving everything. And this was the dawn of big data. I'm sure everyone's heard of that. And the preface to the dawn of big AI, which we're seeing today. So over the next years, I mean, 8 years is a big jump I have here, we saw a lot more SaaS applications, but we also saw a lot of advances in tooling for data engineers and for data scientists, ability to create neural networks at speed. And as things moved from on-prem to the cloud, those folks got busy structuring that data and coming up with different research topics. And they were able to see that through with much greater ease. So I skipped all the way over to 2016 because this is when AlphaGo mastered the AI techniques of deep learning and reinforcement learning, famously defeating the legendary Go player Lee Sedol. He had previously won 18 world titles. So this was a decade before experts at the time thought this type of technology would be possible. So it's moving faster than anyone saw. And AlphaGo's 4-1 victory was watched by over 200 million people worldwide. It inspired players to discover new approaches and arguably became the best Go player in time to history at that point. And it proved that AI systems can learn how to solve the most challenging problems in complex domains. AlphaGo's victory inspired a new era of AI systems, and it was conclusive proof that the underlying neural networks could be applied to complex domains. With the use of reinforcement learning showed how machines can learn to solve incredibly hard problems for themselves simply through trial and error. And that's what you're seeing with agent frameworks today. So its ability to look ahead and plan is something that you'll be able to see in my demo later. So I skipped next to 2018. In October of 2018, Google released BERT. So this was not long after a quite famous paper called Attention is All You Need, which introduced the transformer building blocks for large language models. So BERT is actually one of the first LLM architectures. It's quite simple compared to what we have today, but the team of researchers did something important. They made it open source 1 month later. So they opened the doors for people across the world to learn and experiment from this new type of technology. BERT, this is a mouthful, stands for Bidirectional Encoder Representations from Transformers. And so this transformer-based architecture uses a stack of encoder layers to process text bidirectionally, enabling it to understand the context of words in both directions. Traditional language models before that could only process text sequentially. So this was a big breakthrough. To be fair, OpenAI technically released their transform architecture first in June of that year, GPT-1, but definitely experts agree that BERT gets the credit for defining what we know is now the modern transformer architecture that are in use today. So 2022, we're finally getting somewhere. So at the end of 2022, ChatGPT was shared with the world. Well, some of us. It was released in a researcher preview, and it was based on the GPT 3.5 model. A few months later, March 2023, it was released to developers for API access. I definitely remember this. All of my managers were telling me, we need to have this, we need to put it in the product. And I can't believe like how rapid that is. That was just 2 tree forts ago. We can't stop thinking about it. We can't stop talking about it. It's everywhere. And in that 2 years, a number of companies have released LLMs, APIs, chat UIs, and now the big one this year, agent frameworks. So before we get to agents, it wouldn't be fair to skip past their underlying models. LLMs and other models are the brains behind agents. They're what make agents different from traditional apps that have APIs and automations. And I won't go deeply into each of these or how they're built, or so many more have come out over the years. But I want to talk about some of the more popular ones. I think most folks will have heard of the first 2, Gemini from Google. This comes loaded on your Android phone now, and you can download it on iOS if you want to. And of course, GPT, everyone has heard of ChatGPT from OpenAI, and they have had a big first mover advantage over the last 2 years, but the competition has gotten much stiffer with newcomers. I don't know if people are familiar with DeepSeek, but this is this one that came out in January that really said it's cheaper and it's better. So while they had that first mover advantage and a ton of money to throw at it, we're seeing things change. And then also from Anthropic. So Anthropic was founded by Dario Amodei, who was previously the head of research at OpenAI. He didn't agree with, I don't know, if it was politics or different internal things there, so he started Anthropic. And if I had to say, in the developer community, this is the most popular. Like, developers love Anthropic and Claude 3.7 Sonnet. So while I'd love to talk more about the trade-offs of those, price, speed, if they're open source, if they're open weight, this would make a good talk in and of itself, but I won't get into that today. And most of these LLMs have evolved. Like, they've gained reasoning skills. That's a big word. And also, they're now considered hybrid models, most of them, which means like a multimodal. So they can not only just read text and understand text, but they can handle vision. So they're now calling these VLMs, vision language models. And in the case of the latest from OpenAI, GPT-4o, they also handle audio. So I don't know, it starts to really make you see the anthropomorphic version of these things, seeing and hearing, and then putting it into language, able to give a response back. Again, all in these 2 years. So when models support vision and text, they're able to add a vision encoder, give them the ability to see, process understanding of video, image, and text inputs, and generate those responses. So undoubtedly, this tech is evolving crazy fast, and it's hard to keep up with. So please don't feel like you're alone if your head's spinning and struggling to keep up with these rapid changes. So a little humorous pause. I'm going to take a deep breath and a sip of water. It's a guy from Blink 182, if people don't know the meme, but okay, we're ready to talk about agents. So I'd say the textbook definition of an AI agent is an autonomous software system capable of perceiving its environment, making decisions, and taking actions to achieve specific goals. There are hardware agents, robotics. Again, we won't talk about that side so much, more on the software side today. And these agents use LLMs to generate responses that are able to use tools to take further actions based upon the result of the LLM response, with or without further human involvement. And we'll come back to that point. This user intent driven, so that's what starts it, autonomous capability is what differentiates these agents from virtual assistants or co-pilots or chatbots. Compared to these earlier applications, AI agents are delegated much higher responsibility and degrees of freedom. For example, you may have a business process where 80% of the customer-facing transactions are easily handled. Give all of those to the AI agent to complete those from end to end and push the remaining 20% to a human. And unfortunately, many businesses are rebranding their chatbots as agents, as if these terms are able to be used interchangeably, which leads to confusion. And we've seen this with other buzzwords before: serverless, DevOps, cloud. Marketers will be doing their job to push these buzzwords, and skeptics will question if any of it is real at all. But I believe that agents really are different from these early iterations. Agents can make autonomous decisions and perform complex actions and collaborate with other agents to achieve their goals. And I think that's the main difference between agents and chatbots. So let's take a look at the basic composition of an agent. You could think about agents as kind of having three main components: tools, roles, and a backstory. So tools, capabilities and functions, things like the ability to search the web or through a set of PDFs, or maybe with a database connector, they know how to query certain tables, or specific calculations, distance between two places, or other financial operations and business logic. And then roles. So what are their responsibilities? When you assign a descriptive title, like you are a social media content writer, it implies what it's supposed to do. And a backstory. So I think this is really interesting. You can give it kind of like, what is your resume? And like, what have you done at a previous company? So the example I wrote here is like, as an experienced management consultant, you're an expert in reporting trends in certain industries and making recommendations on new opportunities. You hold an MBA from Harvard and have worked for Deloitte for 10 years. Somehow this changes the tone of how it delivers messages back. So it's really interesting whenever you have multiple agents and teams working together when you give them these roles and backstories. So to take a quick look at Agent Smith's role in the Matrix and some of his capabilities, he was programmed to keep order within the system by terminating human simulacra that would bring instability to the simulated reality, as well as any rogue programs that no longer serve a purpose to the machine collective. He has many superhuman attributes and abilities to bend the rules of the Matrix. He can manifest his physical form by inhabiting and overwriting the simulated body of a human that's wired into the Matrix, and he can move from body to body, reform himself if he's killed, which only kills the host body, and appear virtually anywhere. He can overcome the limitations of gravity and the human body, giving him speed and strength sufficient to dodge bullets flawlessly, punch through concrete with his bare hands, and jump impossible distances. So just to share, that's like a backstory, and it describes some of his roles and capabilities, just to kind of get in your mind a little bit. And in the first Matrix movie, there was only one Agent Smith, and it seemed at the end that Neo was able to successfully delete the program. But as we learned in the next movies, he was not, in fact, removed from the Matrix, but was given additional capabilities, which was to spawn more agents. So not so different from what we're seeing today with AI agent tools and frameworks and the technologies that have launched in the past year. Multi-agent systems is what everyone's talking about. And this is systems that are composed by 2 or more autonomous AI agents that use tools, learn, and collaborate with each other to accomplish a common goal. So a little bit less of a sci-fi example of how multiple agents could collaborate together is you can imagine 4 different roles: a planner, a researcher, an executor, and a QA. So a planner is responsible for setting up the structure of the tasks and create the step-by-step process and stages, this ability to think ahead. The researcher, this is an agent that would access the internet or maybe other internal documents, and it can go through and summarize and create reports from those. The executor, so this is the agent that actually does the task and delivers the outcome. So one example might be to deliver a detailed SWOT analysis. And once the executor finishes, he can pass that task to a QA. We've heard of hallucinations in LLMs, and these issues come up. So you can have a QA agent who is familiar with looking at exemplary work and compare them and say, is this really meeting our quality standard? Can create feedback and pass it back to the executor, so he can then revise. Don't need to give it a gender here. The executor can then revise. So this can go for many steps and stages as you would like, but most of the frameworks allow you to set a limit, because they'll just keep chatting, and it can be very expensive computationally. We see this with humans too, right? Just finish the project, guys. So you kind of can put a step limit as to how many layers each person's allowed to go through that back and forth. So now we have 4 agents and they're interacting with each other. I mentioned before, sometimes you want to insert these stages with a human in the loop to also provide feedback, to say, hey, actually revise this. So that's you interacting with the multi-agent system. And for instance, like if you're sending something customer-facing report, really high stakes, you might want to have someone put a set of eyes on it. But in other systems, you might not. That's just like that drag, that stopping can really hinder your business. So it just depends on the use case, and you want to make sure it meets your standards for what you're looking for. So great. Now we have a basic understanding of LLMs and agents and multi-agent systems. At least we've described them at a high level. So I'd like to do a little show and tell. And we've all had this colleague, they hate meetings. He used to like to say, talk is cheap, show me the code. He said it all the time, and I just loved it. It stuck with me. But before I show you the actual code, which will be in Python, most AI code is written in Python, and that's where we're going to focus today. Before we get there, I want to share the agent framework that I chose, its philosophy, its architecture, and then I'll show a real-life example that I prepared for this talk, and then a little bit of the code, and we could see how the agents interact with each other. So this is an image I found on lovely LinkedIn, which has become like TikTok these days. The AI agents infrastructure stack is like changing super rapidly. Most of these companies, I know you can't see them all, tools and services, these didn't exist a few years ago. I would argue most of them probably didn't exist a year ago. So every single week, things like this, map stacks are created or previous versions are updated to include the latest and greatest 10 tools. I've spent months looking at these, and like as I prepared for this talk, I wanted to pick some that were easy to understand, could demo well, I could explain them, and maybe y'all could get started with too. So pick these 2 little ones. So the agent framework I picked was from Hugging Face, and the framework's called Small Agents. If you're unfamiliar with Hugging Face, it's an online platform dedicated to data science and machine learning. You can browse data sets, train AI models, share your work, collaborate with others. I like to think of it as the GitHub for AI. I chose LangFuse as an observability tool. So this will help you as you're working with LLMs and agents to trace and kind of debug your messages and interactions with the different LLMs. So it has like a dashboard that helps you trace how changes to one prompt or a step in your agent can impact the overall performance. And it works with any open LLM and any API. So Hugging Face introduced small agents in December, not very long ago. And there are plenty of other frameworks out there. It's a Python library designed to create these agentic systems with minimal complexity. And there are other more robust agent frameworks like Crew AI or AutoGen. Small Agents focuses on simplicity and efficiency, packing all of its functionality into about 1,000 lines of code. I could show you, it's because it's open source as well. It's about 1,200 lines of code, so really powerful. And why it stands out to me, I think it distinguishes itself with a code-centric approach. Instead of relying very heavily on you putting together these templates or API schemas of exactly what it should expect, Small Agents does this directly in code. That means it generates the code itself dynamically, and it can recover and rewrite its faulty code when it realizes, oh, that code I wrote doesn't work. Ultimately, this reduces those API calls or those LLM compute calls, which enhances your performance, and it makes it more cost efficient. As I thought through this more this past week, it kind of reminded me, if there's developers in the audience, of functional programming. It changed the paradigm of how we thought about writing code, where it's writing itself in some ways. So some of the key features: it's minimalist, it's lightweight, it focuses on just essential features. It supports both open weight models, which you can load in through Hugging Face, and also proprietary models through APIs, something called Light LLM, if folks are familiar. And it's really easy. Your first agent can take 3 lines of code makes it very accessible. And I'll show you how that looks in a little bit. So back to definitions. I put the little small agents logo up there because I want to start to use the language that they use. So in case you want to pick it up after, you'll think about it that way. So an AI model is something capable, an agent is an AI model capable of reasoning, planning, and interacting with its environment to fulfill tasks. So think about it as having a brain, the LLM models, and then having a body, which represents the capabilities and the tools. So for the brain, this is where the thinking happens. The AI models the reasoning, the AI model handles the reasoning and the planning, and it decides which actions to take based on that situation. And the body, this part represents everything that the agent is equipped to do. So the scope of possible actions just depends on what the agent's equipped with. So example, humans lack wings, so we cannot perform the fly action, but we can execute actions like walk, run, jump, grab, etc. And tools, they define a tool as a function given to the LLM that is meant to fulfill a clear objective. A good tool should be something that complements the power of an LLM. The LLM only contains knowledge about the events prior to its training. So if your agent needs up-to-date data, something that's happening now or about to happen in the future, you must provide that through tools. So LLMs receive the text inputs and they generate text outputs. That's what they do. They don't have the ability to make the API call themselves. So we teach the LLM about the existence of tools and small agents, and then ask the model to generate text that invokes those when it needs to. It's responsibility of the agent to parse the LLM's output, recognize that a call is required, and then invoke the tool on the LLM's behalf. So here you can see some of the more commonly used tools in AI agents: web search, scraping data from web pages, and image generation, and pulling data out of a database or from an API. You can write a tool to do anything, and that's the beauty of it. If you describe your tool in small agents with the doc strings of just explaining what the inputs and the outputs are and what its purpose is, when you're just collaborating with it, and agents, oh, I think I have a tool that does it. It's like going to your shed and just saying, yeah, I think this will do the trick, and it's looking around for things that meet that criteria. So now that we've explored the brain and the body, let's take a deeper look at the mechanics. Small agents refers to this as the thought, action, observation cycle. Thinking, acting, observing. So thoughts, this is the LLM part of the agent that decides what the next steps should be. Action, agent takes the action by calling tools with the appropriate data. And observation, the model actually reflects on the response from the tools and it decides what it wants to do next. So in order to build effective agents, you can think about that cycle as a loop that continues until the objective is fulfilled. I find it helpful to think of iteration, integration, adaptation. This is IIA, I just really stick that in my head. So iteration, it starts with a thought, acts by calling a tool, observes the outcome. If the observation indicates that it's an error or they had incomplete data, not able to fulfill its task, re-enter the cycle, correct your approach. Integration, so this is the ability to call tools, the ability to call a weather API. This enables agents to go beyond the static knowledge of the LLM and retrieve real-time data, which is an essential aspect of many AI agents. And adaptation, probably the most crucial. Each cycle allows the agent to incorporate fresh information as observations into its reasoning, thought, ensuring that the final answer is well-informed and accurate. And I mentioned this earlier, but sometimes things go sideways. LLMs are known to have hallucinations, and as they're the brain of agent systems, these things do happen there, and things go off the rail. I like to sit back with some popcorn and watch it. It's like so confused, and like you asked it to do this thing, and it's like very close, and then it's like, but what about this? And it just goes way over here, but it can recover. And it's just, quite entertaining to see that adaptation and watch itself create new code and try new attempts to fulfill those tasks. So let's look at the thought, action, and observation layers a bit deeper. So thoughts represent the agent's internal reasoning and planning processes to solve the task, utilizing the agent's LLM capacity to analyze information when presented in its prompts. You can think about it as an internal dialogue where it considers the task at hand, and it strategizes its approach. So through this process, the agent breaks down complex problems into smaller, more manageable steps, reflects on its past experiences, and it continuously adjusts its plan based on new information. So some common types of thoughts include planning, decision-making, goal setting, prioritization. There's more up here. And I find it really interesting how the agent is thinking. It follows what's called in the space a react approach. Reasoning plus acting is react. And react is a very simple prompting technique, and you can use it with LLMs in your ChatGPT app as well. It's just actually just adding the text, let's think step by step. And before letting the LLM take on its next input, you just remind it to do that. And this prompts the model to think step by step, encourages a decoding process to generate a plan rather than a final solution. But again, it can keep planning too, and sometimes you need it to get to an answer, so it could be frustrating. But the model is encouraged to decompose the problem into a subtask. So this, whenever they said how did DeepSeek achieve overcoming what OpenAI did with much cheaper hardware, this was the technique, to think before answering. Just adding that little step, they were able to do it on much cheaper hardware and get better responses. So now OpenAI is also using that in their latest model. So actions, I think these are pretty straightforward. We talked about these concrete steps an AI agent takes to interact with its environment, information gathering, doing a web search, querying a database, using tools to make API calls or executing other code for calculations, and communication, engaging with users via chat or collaborating with other agents. It's a list of actions to engage with your environment. Observations are how an agent perceives the consequences of its actions. So by integrating feedback, it's able to reflect and adapt. Agents receive signals from their environment. It could be data from the API, there could be error messages, there could be system logs. These all guide the next cycle of thought. And in this phase, they collect feedback, that data or confirmation, was the action successful or was there an error? It appends these results. So it adds that new information into the existing context in what we call updating its memory. It's putting that in the memory stack. And then it adapts its strategy. It uses this updated context, and it can refine subsequent thoughts and actions. This is another iterative incorporation of feedback to ensure that the agent remains dynamically aligned with its goals, it's constantly learning, and it's adjusting based on real-world outcomes. So it's kind of wild, but I hope it kind of also makes sense. Some of it feels intuitive, like very simple. It's kind of mind-blowing, but like I find it almost straightforward in a way. Excuse me. So now that we can see our agents are thinking and acting and observing in this cyclical manner, how do multiple agent systems work together to fulfill tasks? Small Agents talks about multi-agent systems as the ability to enable specialized agents to collaborate on complex tasks. So you might say, why not just have one agent that can do everything? This improves modularity, scalability, and robustness. So instead of relying on a single agent, tasks are distributed among agents with distinct capabilities. So one setup might be for a manager agent to do task delegation, and a code interpreter agent to do code execution, and a web search agent for information retrieval. And a multi-agent system often consists of these multiple specialized agents working together under what's called an orchestrator agent. And this type of approach enables these complex workflows by distributing the tasks among agents with distinct roles. So, similarly, you could have a web agent to browse the internet, retriever agent for fetching the information from knowledge bases, and then one more agent to generate images to produce the visuals. So all of these work under the orchestrator that manages the task delegation and interaction. What's important here is multi-agent structures allow us to separate the memories between the different subtasks, and this gives us two great benefits. One, each agent is more focused on its core task, thus more performant. And two, separating memories reduces the count of input tokens at each step, which does reduce the latency and the cost. So by now, you're wondering, is he ever going to show the code? I said, talk is cheap, show me the code, and then I just rambled for another 15 minutes, and I promise you we're getting close. So I used small agents to develop an agent system for a friend of mine. He's a local musician, which is very relevant because he's playing at Treefort this week, so I thought it was a good use case. He goes by Dr. Tom. I don't know, maybe some of you have heard of him if you're local, but he's a professor of music at the College of Idaho. And he also makes underground electronic dance music. So he founded a local nonprofit called Under the Trees, puts on like free EDM shows in the park, beautiful locations around Boise. And he's also a resident DJ at Space Banana, just a few blocks over on Bannock Street. He's performing on Saturday night if you're into that kind of thing. But let's talk about his agent use case. So Tom's a super busy guy. So he commutes to and from Caldwell every day for university. That's like an hour each way. He produces new music all the time. He's trying to create new music constantly. And he's also mentoring aspiring producers in Boise. And he's organizing these events, working with the city on permits and venues and photographers and videographers and all the staff. So he's a busy guy. And we were talking the other day, well, it was a few weeks ago now, but he shared with me that he wants to get his music, not just in Boise, but he wants to get it out there to other cities, and thought maybe I could start touring this summer. School's out, maybe I could get to some other nearby cities. And it was like more things for this poor man to try to figure out. What you love about entrepreneurs, they want to do everything. So the light bulb kind of went off. I was like, I'm going to build him a booking agent. And rather like a multi-agent system to help him figure this stuff out. And so we got started. I worked with him to kind of draft a concise goal, what Tom wanted to get out of the system, and this is where we landed. I wanted to build a music talent booking agency that Tom can utilize to design his tour, find appropriate venues and contacts, tap into local communities and influencers, and create on-brand buzz that will be relevant to his new fans. And I then broke that down into like a set of capabilities that you would expect to see at a booking agency. Secure bookings, negotiate performance opportunities and with venue managers and festival organizers, negotiate contracts, handle financial and contractual aspects, riders, tour routing and logistics, super important. So what's the tour itinerary, efficient travel and accommodations, communication, interacting between the venues and promoters, building relationships, so cultivating relationships with local players in the music industry, and admin tasks, handle paperwork, receipts, other admin tasks related to the business, and team collaboration. Want to make sure there's a cohesive approach and a healthy team relationship happening here. And so for the initial version, that was a lot to try to build out and explain, but I decided to focus on 3 capabilities: securing bookings, tour routing and logistics, and building relationships. So after some trial and error, I decided I wanted to develop a 5-agent system. First, have an agent responsible for the others, the tour manager. He oversees all operations. I use that he again, and is responsible for the work of the 4 specialized agents. And I wanted someone doing the research. So what venues are suitable? For example, they could be clubs, but probably not stadiums or really large venues. He's relatively unknown. And he may not be able to, fill the place. So what are some nearby places to stay is something this researcher might also look for. And then I thought this was a funny one, the vibes agent. So this is like the hipster who knows like the scene, they know what's happening on Instagram, they know how to look at a city and say, that's on brand for you, that's what you should do. So there might be suitable by size in one way, but how's it gonna fit your brand and be a good venue for you to play at? And the logistics coordinator, so this is responsible for actually booking things, the gigs at the venues, reaching out on email, coordinating different arrangements with them, also for making the bookings at like accommodations. So this would need tools, APIs to interact with Airbnb, APIs to interact with hotels.com. And last, I added an ops admin who kind of summarized the activity as they worked on things and reports back to the tour manager if anything's going wrong, or kind of like here's where we're at. And I don't know if this is gonna. I'm a nerd, but. Okay, so now that let's let these bad boys out, and let's see what they look like in code. Multiple agents attempting to achieve a common goal. So show me the code. I promised you I would, and I'm gonna actually try to scoot over here. Hopefully the editor might work. I brought some backup code in case, but real code. So simple app booking agency. It's like 153 lines, and that's with these ridiculous comment things in there, so it's much less. It's like 100 lines of code for sure. And so you need your imports. You know, from the small agents library, there's different things you bring in. The Hugging Face API model, so that's the ability to use all the different models that they host on their platform, or the Light LLM, which you can pull out to any one that they support, which is like thousands. A code agent, search tools from Google, from DuckDuckGo, a visit web page tool. And then some of this stuff, not that exciting, but I'll show you if we have time, which is the ability to trace those LLM steps and see where things went wrong. So it's just that easy to kind of pull in some keys and send each trace of all of the interactions of your agents. You just implement that. So models, this is how easy it is to work with an LLM. You can do this, so this app is running locally on my computer, but I am calling out to Google's API. I could run their models locally, or I could run DeepSeek locally, not pay anybody any money, just have it running here. But for simplicity's sake, I'm just gonna reach out to theirs. So it's as simple as, so this is Gemini 1.5 Flash. I can just make it 2.0. And that's all you have to do, is know the name of the model and put it in. So Qwen, this is another more popular one this year. This is from Alibaba. And DeepSeek, which is, you know, taken a lot of the news headlines this year. And you can give each agent its own model. If one of their tasks is more about coding, you could give it a very specific model that is better at coding. And so it might be expensive, but giving that coding model to your social media content writer doesn't really make sense. In this case, I'm just kind of using the same model and just seeing how it performs so I can see where it falls down. So that's really the way to create the models. And then tools, so there's kind of, to perform these actions, I would have liked to had it reach out to Airbnb, had it reach out to hotels.com, these API tools. You can create your own tools. I didn't for the sake of this, but some of the onboard tools are Google Search, DuckDuckGo Search, and Visit Web Page. That enables your agents to do a lot, to get out there and perform queries, and then you can write little parsers to pull the data out. Agents, so this is how an agent looks. So you remember the research agent? You give it a name. So whenever the manager's like, who can I have do that? I have a research agent. They're familiar with that. And so just a name and a description. And again, you can go very deep. You can give it a big backstory like I did with Agent Smith, whatever works for you. But it's like when you're orchestrating the team, they know based on these descriptors who to reach out to for that. And you can see it kind of, you know, just like in the real world, it's like, is Bob doing that or is Linda doing that? They both kind of do that work. So sometimes the manager's like, I don't know, you guys figure it out. And these are other things. I mentioned max steps. Don't keep doing it. So this is nice to kind of not overthink it, because it'll just get into some weird territory. There's the vibes agent. So you're a tastemaker, you know how to network with local scenesters. And the logistics agent, you're an experienced venue booker and travel planner that coordinates all lodging, flights. And the ops admin agent, which is responsible for kind of like the updates and if any issues arise. And finally, the manager. So the manager is responsible for booking venues for a music tour, and you need to coordinate with these agents that you manage. So this is all you have to do to tell it that you're the manager of those other agents. I give it a little bit more time to plan. Sometimes I change its model, maybe a better reasoning model than the other ones that don't need that reasoning ability. And then whenever you do visualize, you actually get to see an org chart. So we looked at that code. Well, yeah, first let me read the task. So find the best venues in Montana for electronic dance music. Coordinate with your team to identify which are the most appropriate for Dr. Tom. You can learn more about Dr. Tom at his website, drtom.music. He prefers venues like this one, Space Banana. Get the contact information for those venues and check their availability for summer 2025. I didn't put in that at first, and it was like, we don't know the tour dates. What's this? We don't understand what you're asking us. They get really a little testy. So we will be leaving from Boise. Once you have a list of venues, check for nearby hotels or Airbnbs, then check the driving distance between venues and lodging. Finally, summarize your findings. You can't see this at all, and you won't be able to see it if I execute it here too. But this is the org chart. So at the top, you see the manager, and then you see the different agents that work under them and their roles and what tools they have access to. So it's kind of a sanity check of like who's on the team and what do they do here. And in this case, oh gosh, this is so hard to read. You can't read it. Oh, by the way, this deck will be available at my website /hackfort. So that's on the last slide if we don't get there. But yeah, let me see if I can try to decipher this. So this is the initial plan. I mentioned the think, act, observe. So you'll see the little thing at the top, think. Okay, let's start breaking down the task. The main goal is to find the best EDM venues in Montana for Dr. Tom, coordinate with the team, get contact info, check availability, find lodging, check driving distances, and summarize everything. First, I need to figure out Dr. Tom's preferences. His website probably has info on his music style, past venues, or audience. The research agent can handle that. So step one, have research agent analyze Dr. Tom's website to understand his needs. Next, identify potential EDM venues in Montana. The vibes agent, being a tastemaker, would know where to look for local scenes. Step two, task vibes agent to find EDM venues in Montana, considering his style from step one. Once venues are listed, we need to get their contact info and check availability. The logistics agent, experienced in booking, should contact the venues. Here, but wait, we need the tour dates first. So in future runs, I did put summer of 2025, and it helped a lot. But I won't read all of it, but it's thinking. So that's the end of the think tag right there. So summarizing again to itself, it's printing it out. I can read it, I did, but research Dr. Tom's preferences, find EDM venues in Montana matching his style, confirm tour dates, check venue availability, and get contacts, find lodging near each available venue, calculate driving distances from Boise to venues and between venues and lodging, summarize all info. So it's thinking and continuing to refine its plan and then assigning those tasks. Task, task, task. So all the different people have now run off and do their tasks, and they spit out similar output. So for like the case of ranking venues, so like the vibes agent put together this algorithm, you can tweak it because it gives you the code and then you can put it back into your application, like on genre, atmosphere, size, and they weight those different scores. And then it actually found the vibes agent and the admin assistant then summarized this, that the Wilma in Missoula is a 4.5, the Rialto in Bozeman 4.2, knitting factories, we have one of those here, 4.0. So it came up with a list of what we think are important to Dr. Tom's preferences: tech house, melodic techno, atmosphere, intimate and energetic. And he hosts these like kind of unique events. Like Spaceman is small and a little bit different, and he hosts all these outdoor parties. So it's like, this guy's a little weird. He does it a little differently. It's just funny to think it, like break him down as a person and think what's gonna work for him based on information that it can find on the internet about him. And same with venue characteristics. Do they play house, techno, or indie, or more electronic? And it like looks at what a venue's website might have about it and say, we think that's a fit. And so this was the admin assistant sort of monitoring the updates from the other three agents, logistics agents secured necessary resources and coming up with like enum types so it can understand what would I want to report about their progress. And it's thinking and generating the code to do that. So we're actually 1 minute past time. So I mean, I can press play if you guys don't trust me. But so I'll try to pull this out. So that's, it gets its initial thing. If you have an issue with your model that you're using, it'll tell you right away, like you're out of credits or this model doesn't work or whatever it is. And the internet here is quite slow, but yeah, so that's it, generating its task list again. Use this agent to do that, compile those, task those people. So analyze his preferences, visit Dr. Tom, analyze Space Banana, compile a list of criteria. This is what I was saying. It was just kind of funny what it was saying about it. So yeah, summer 2025. Oh, so June through August. It's just it's able to use language to do things like that. It's a way different way of programming. A programmer used to have to put in this date range to that date range. It just can interpret language in this really easy way. So obviously I'll share this deck. I'm happy to connect with people after this talk. If you have to get running to the next one, I just want to be mindful of that. And where am I at? This, no. Okay, I can go back up here. Yeah, just quickly, I wanted to spend more time with you to talk about different use cases in different industries, just to kind of plant some seeds for you to take away from here. Again, I'll share this, and I wanted to hear what else you were up to, but we could talk after. I don't think there's anyone in this room. And in the words of Agent Smith, never send a human to do a machine's job. Thanks for coming. I really enjoyed this, and you can find me up here.